Mr. Clelland here for Clelland Maths. Today we're going to be looking at expanding double brackets. First thing we'll just do is look at how to expand double brackets. There'll be a couple of methods that we use for that, and I will go through the preferred method, but you can use any method that I give you. Then we'll be looking at what happens when we take a bracket and square it. Then we'll look at some problem solving questions types where, like in the previous video, you had to look at things like if it was area and brackets, how you could combine the two things together, area and algebra. Then the last thing is we'll look at expanding double brackets, but not in the standard form. Things like where there's two things in the first bracket, but three things in the next bracket. So, part one, expanding double brackets. And we're going to look at method one, the grid method. So the first example says expand 2x add 1, 3x add 2. And what we can do is we can represent that as a grid. So if I draw a box, then on one side we could have our first thing, which is 2x plus 1. I'll leave a gap. And on the other side we could have 3x and then add 2. And we can think of it as working out the area of this whole box, which would be times on both sides together. Now if I split this up, my box up, like so, then all we need to do is times everything by everything else. So 3x times 2x is 6x squared. The next box is 3x times 1, that gives me 3x. The next box is 2 times 2x, which is 4x. And the last box is 2 times 1, which is 2. And just like when we do times in the grid method, when we're using numbers, we add up all our answers at the end. So the final answer will be 6x squared plus 3x plus 4x plus 2. And you should be able to see that these terms in the middle the 3x and the 4x, are the same type of term, so they can be added together. So the final answer becomes 6x squared plus 7x plus 2. And that's the final answer. So that's method one, the grid method. Let's look at another method. So looking at exactly the same example, expand 2x add 1, 3x add 2, we can use the method of splitting the terms. Because what we can split it up into is two separate single brackets. You've got 2x has to be times by 3x plus 2. And then I've also got add 1, and that also has to be times by 3x plus 2. So all I've done is split it up. Instead of saying it's the whole of 2x add 1 times the whole of 3x add 2, I've said that it's 2x times the 3x add 2, and it's 1 times the 3x add 2. And we just then expand those single brackets like we did in the previous video and simplify. So your answer would be 2x times 3x is 6x squared. 2x times 2 is 4x, and then for the second brackets, 1 times 3x is 3x, 1 times 2 is 2, so the final answer is 6x squared plus 7x plus 2, which is exactly the same answer we got previously, so it doesn't actually change anything, it's just a different method. Okay, let's look at one last method, which is a bit of a trick because it only works with expanding double brackets where there's two terms in each bracket. So it won't work when there's maybe 2 in one and 3 in the other. So bear that in mind if you do use this method. It's really just a mental trick to help you remember the order you need to times by. And it's called FOIL. Now FOIL stands for first, outside, inside, and last. So you've got first, outside, inside, last, FOIL. And if we can see how to use that in the same example, so it's expand 2x plus 1, 3x plus 2. So I'll use different coloured pens so you can see what's happening. So the first thing we're going to do is look at the first word first. First just means times together the first things in each bracket. So in other words, 2x times 3x, because they're both the first. So I do 2x times 3x, and I get 6x squared, and I write down the answer. Outside, I'll use a different coloured pen. Outside means times the outsides of the brackets, so the 2x and the 2, the outside ones. So it's 2x times 2 in this case, and I can write down plus 4x. Inside is the inside of the brackets, so it's a 1 and a 3 of the inside, so it's 1 times 3x, which is 3x. And then, last but not least, the one that said last, it's the last things in each bracket, so it's a 1 times a 2, which is 2. So last is yellow, inside is blue, side is purple, and first is red. First, outside, inside, last. And then as per usual, once we've got our 4 answers, we simplify by adding the 2 ones in the middle. So we get 6x squared plus 7x plus 2 again, which is exactly the same answer we got before. Okay, let's look at a few examples. Example 1 says expand and simplify x add 2, x add 3. And I'm going to use the grid method for this and then quickly show you the other methods as a quick check so you can decide which one is best for yourself. So using the grid method, I just draw a box. I write x plus 2 and then x plus 3, my 2 brackets, and I split it into 4 because there's 4 things. X times x is x squared. Second box, I need to do x times 2, 2x. Third box, I need to do 3 times x, 3x. And then the fourth box, 3 times 2 is 6. So the final answer is everything in the box added together. So I've got x squared plus 2x plus 3x plus 6. And remember, it's the 2 middle ones that are always the ones that we end up adding together. So we end up with x squared plus 5x plus 6. And that is doing it using the grid method. We can check our answer with FOIL if you want to. So if I do it again, x plus 2, x plus 3, and I'm going to write FOIL at the side to remind me. I do the first, x times x, which is x squared. The outside, x times 3, 3x. The inside, 2 times x, 2x. And then the last, 2 times 3 is 6. I should get the same answers I got before. I did, so it's good. So obviously the answer is still x squared plus 5x plus 6. I will do the other method just for the sake of completeness, which is splitting the brackets into 2 single brackets. We'll do that underneath. So we had x plus 2, x plus 3. Use a different coloured pen. So I need to do x times the second bracket, x plus 3. And then I need to do 2 plus 2 times x plus 3. Expanding both the brackets, I get x squared plus 3x plus 2x plus 6. So in total I've got x squared plus 5x plus 6. Same answer no matter what way I do it. Let's look at a second example. Okay, example 2 says expand and simplify 5y plus 7, 3y minus 4. So the first thing I'll do is draw a rectangle. I'm going to do it by the grid method because I think that's easiest to see what's happening. So I've got 5y plus 7 on the top, and down the side I've got 3y minus 4, and I split my grid into 4. So the first one I need to do is 3y times 5y, that's 15y squared. The next one I need to do 3y times 7 is 21y. The next box underneath, minus 4 times 5y, minus 20y. And then the last box, minus 4 times 7 is minus 28. Putting it all together, the final answer then is 15y squared plus 21y minus 20y minus So putting it all together, the final answer is 15y squared plus 21y minus 20y minus 28. And it's the two terms here that we need to put together. So plus 21 minus 20. Well, 21 minus 20 is just 1. So the final answer is 15y squared plus 1y. So just y minus 28. Okay, part 2, squaring brackets. Example 1 says expand and simplify x add 3 squared. Notice the squared is outside the bracket, so it means the whole bracket is getting squared here. So all that means, like when you square anything, is times it by itself. So I've got x plus 3 times by itself x plus 3. And now the problem is just turned into what it is like in the previous examples. So I can just draw a grid. X plus 3 on the top, but this time down the sides it's exactly the same. X plus 3, split it into 4. X times x is x squared. X times 3 is 3x. 3 times x is also 3x. 3 times 3 is 9. Add everything together, I get x squared plus 3x plus another 3x plus 9. The middle terms get added together, so I've got x squared plus 6x plus 9. And it's just as simple as that, not really any harder. Okay, example 2 says expand and simplify x plus 2 squared plus 2x plus 1 squared. So you've got two sets of brackets that are getting squared. So I've just got two sets of sums to do. So if I draw it out, the first bracket one, rectangle, I've got x plus 2 on the top, x plus 2 down the side. Split it into 4. But then for the next bracket, I've also got a rectangle. But this time it's 2x plus 1 and 2x plus 1 down the sides. So I do it as two separate sets of problems. First problem's x times x is x squared. X times 2 is 2x. 2 times x is also 2x. 2 times 2 is 4. Next one, 2x times 2x is 4x squared. 2x times 1 is just 2x. 1 times 2x is also 2x. 1 times 1 is 1. Add everything together inside the brackets. Inside the grids. So from the first grid, I've got x squared plus 2x plus 2x plus 4. And from the second grid, I've got plus 4x squared plus another 2x plus another 2x plus a 1 on the end. Remembering how to expand and simplify. The simplify part is going to come now. I look at my first term as x squared. I just go along the line to find another x squared. There it is here with the plus in front. So I do x squared plus 4x squared, which gives me 5x squared. And now go back to the start. Maybe even pick a different colour for my highlighter. I've got 2x, so I'm looking for things that have just got x, plus another 2x. 4 doesn't count, so the next one is plus another 2x. And then the next one after that's plus another 2x. 2, 4, 6, 8. I've got 8x in total, so add 8x. And then the last terms are the ones that are not highlighted yet. I've got plus 4 and a plus 1. So I've got 4 plus 1 is 5, plus 5, and I'm finished. Okay, part 3, problem solving. Now, if you look at my last video on expanding brackets, it was not just single brackets, but there was also a problem-solving section in that video, and it was all about when you had the algebra and you had to write down an expression for the area of, say, a rectangle or a triangle, and then maybe expand and simplify. This is just exactly the same. So I'm only going to do one example like this, but if you go back to my previous video, you'll see how it works in the context of single brackets, which is exactly the same as how it works in double brackets. So example 1 says, write down an expression for the area of a rectangle and simplify, and it shows us a rectangle, 2x add 1 and x plus 2. So the first thing I suppose we need to know is, what is the area of a rectangle? Well, the area of a rectangle is the length times the breadth. Well, there's my length here, and there's my breadth here. So it has to be 2x plus 1 times x add 2, but now I've got a problem. I need to times by the whole of x. 2x add 1 times the whole of x add 2, so I'm going to need brackets. So length is 2x add 1, so I'm going to need brackets because I'm going to have to times the whole of 2x add 1 times the breadth is the whole of x add 2. So I now see what I need to do. I need to do 2x add 1 times x plus 2, and I just solve that in the same way as I've solved all the previous examples in this video, using either FOIL or the grid method or the other method that I showed you. I'll use the grid method because it seems to be obvious in this case to do that. So I've got 2x add 1 and x plus 2. I split it up in times. So I get 2x squared. 1 times x is x. 2 times 2x is 4x. 2 times 1 is 2. So the final answer is 2x squared. 1x plus 4x is plus 5x plus the extra 2, and that's me finished. And all of them are like this. The only difference you might find is if you had a triangle, if you look at the previous video, then you have to half the answer first or half at the end. Okay, the last thing I'm going to look at in this video is expanding double brackets of a form, and it says ax add b dx squared plus ex plus f. What that's trying to say there in simple terms is one bracket has 2 things in it, and the other bracket has 3 things in it. So if you look at all the previous examples in this video, each bracket has always had exactly 2 things in it, and we've used a method to solve and expand them. Now, I've already said this briefly before, but I'll say it again. If you have been using FOIL to expand the brackets up to this point, it will not work for this type of example, because FOIL only works when you've got the 4 things, 2 in each bracket. So you have to use either splitting up the brackets into 2 separate single brackets or the grid method. My preferred option for this, because you can see exactly what's going on, is the grid method, and it shouldn't let you down. So I'm going to use the grid method for this. So it starts exactly the same way. If the example says expand 2x add 1, 3x squared add 4x add 5. So I draw a rectangle. Make it quite big on your page. Okay, so I'll put my 2x plus 1 down the side. That's my first bracket. Doesn't matter what order you do your brackets in, but I'll do that down the side so I've got more space at the top. So at the top I've got 3x squared, leave a space, plus 4x, leave a space, plus 5. So I cut everywhere there is something. So I've cut it into 6 boxes. Now there's a quick check to tell if you've done the right number of boxes. There's 2 things in the first bracket, 3 things in the second bracket, 2 times 3 is 6, so I've got 6 boxes, that's correct. Okay, now we just times everything together as we've done before. So the first box is 2x times 3x squared. Be very careful here, you get 6x cubed. Squared times single gives you cubed. Watch your signs, watch your indices, watch everything when you're doing these. The next one, 2x times 4x, 8x squared, because x times x is x squared. Last box on the top line, 2x times 5, well that's just 10x. So now we go underneath. 1 times 3x squared, that's just 3x squared. 1 times 4x, that's just 4x. 1 times 5, that's just 5. So as before, we now just add everything in the boxes, starting at the top. 6x cubed plus 8x squared plus 10x plus 3x squared plus 4x plus 5. Using our highlighter method to simplify this. So you've got 6x cubed. I can highlight that and look along for x cubes. There's no more x cubes. So I'm done with him, so I write him down. So that's 6x cubed. Next colour highlighter. I've got 8x squared is the next thing. So x squared. I look along and look for more x squareds. 3x squared. 8 and 3 is 11. So I've got 11x squared. Next colour highlighter. I've got 10x is the next thing. So I'm looking for just x plus 4x. 10x plus 4x is 14x. So I've got plus 14x. And then the last thing you should be able to see on the end, but I'll highlight it anyway, is on its own, just the 5 there. So it's just plus 5. So it's just plus 5. And that's my final answer. I'll do one more example like that. So example 2 says expand and simplify. 2x minus 1, 3x squared minus 2x minus 2. And I've deliberately made the last question the hardest question with negatives everywhere. So we'll have to watch our signs and our double negatives. But we start in exactly the same way. By now you should know what to do, but you draw a box or a rectangle. Down the sides, the first one, 2x minus 1. And up the top, second bracket, 3x squared minus 2x minus 2, and split your box up. Now we times everything together, watching our signs and watching our indices. 2x times 3x squared is 6x cubed. 2x times minus 2x is minus 4x. I've only got one negative, so the answer is negative. 2x times minus 4x squared. That's where I say watch your signs, watch your indices. Next one's 2x times minus 2x, which is minus 4x. Then look into the bottom line. Minus 1 times 3x squared, minus 3x squared. Minus 1 times minus 2x, double minus makes a plus when you times them. So you've got plus 2x. And then the last box, minus 1 times minus 2 plus 2. Then we add up all our boxes. So that gives me, inside the boxes, 6x cubed, minus 4x squared, minus 4x, minus 3x squared, plus 2x, plus 2. Get my highlighter out so I can simplify it. So the first thing is 6x cubed. I look to see if there's any more x cubes. There shouldn't be, and there isn't. So I've got 6x cubed for my first one. Highlighter again. Minus 4x squared, and minus is important. Look for another x squared. Minus 3x squared. So the sum I'm doing is minus 4 minus 3, which is minus 7. So it's minus 7x squared. Watch your signs here. The next one is just the minus 4x. So I'm looking for another one with x plus 2x. So you've got minus 4 add 2. Well, minus 4 add 2 is minus 2. So it's minus 2x. And then the last thing on the end is add 2. And that is another example for that, and I'm hoping that you could follow that and that was useful for you. Okay, this is Mr. Clelland from Clelland Maths. Hope that video was helpful. If you did, give it a wee like and a thumbs up, and remember to subscribe for our next content every week in the National 5 playlist. Hope to see you there. Thank you very much.